Today we're working on lesson 3-1 out of Big Ideas book. It is the Big Ideas book. This week I'm going to give you quite a bit of homework on Tuesday, Wednesday, Thursday, but for the first time in probably the last 12 years, I am not giving a winter break homework packet. So work hard, play hard, all right? Today we're covering relations and functions, a lot of new words: relation, function, domain, range, independent variable, dependent variable, continuous, and discrete. And basically what we are covering now will set you up for the beginning of the year project where you will be drawing lines with graphing calculators, utilizing your domain and range, okay? So please copy these words down. By the end of this class, you should know what all these words mean. All right, so let's look at some real-world situations. We're going to look at independent and dependent variables. Okay, Beta drove to work at 45 miles per hour. She pulled over at a gas station to look for her purse. She then raced home at 60 miles per hour to find her purse. Graph her distance from home over time. Okay, we're comparing two things. What are we comparing? Yep.
How long she drove to work and how long she raced home.
So if I were graphing it, the x-axis and the y-axis, what would the two topics be? Give me one word. Yes?
Distance and time.
Distance and time. Okay, what is the depender? Because the depender goes where the y is. We've been talking about that. What is the depender, McKenna?
The time depends on the distance.
Time depends on distance. So how far I go depends on the time? I have another, what did you say? Distance. Go on, repeat it.
Distance depends on time
Because?
because how far you drive. If you drive for an hour, that depends on how long, how many miles per hour.
So he's saying the time depends. Now we have opposing opinions. Sav.
I disagree. I think that the time depends on the distance because
That's what he's saying. You two are saying the same thing. You said time is the depender. You're saying time is the depender. She's saying, let me hear your explanation.
I just think that because if you're driving 10 miles, the 10 miles isn't going to...
Hold on. Okay, go on. One more time your explanation.
I think that the time is dependent because if you're driving 10 miles, the 10 miles isn't going to change, but there's different things that can change the time, like the speed that you're going, if there's obstacles in the way, just different things.
Okay. Well, actually, it is in fact that time, your distance is your depender. Your distance is depends on how much time you drive. If I only drive for an hour, I can only go 60 miles. If I drive for 2 hours, I can probably go 120 miles. If I drive for 3 hours, I can drive. So it's actually distance is your depender, where time is your independent. Okay, so if that is the case, once you decide what is your independent-dependent relationship, if your depender is your distance, that goes on the y. You're going to set it up in your graph, and you're going to go, distance goes on the y-axis, and time is on the x-axis. FYI, time is generally, I will say 90% of the time, it will be on your x-axis. It is the independent. But I have seen a couple situations in that LAUSD is set up for some like performance tests where I've seen them set the time up as the depender. But for the most part, distance is dependent on how long you get to drive or the time. So, knowing this, when Beta drives to work at 45 miles per hour, she's pulled over. So let's look at the first thing. Let's do our first line. There she is, driving 45 miles per hour. Now, she's pulled over at a gas station to look for her purse. What's that line going to look like? What's the line going to look like, McKenna?
It's going to be just a straight line going horizontally.
Horizontal.
The time is increasing, but the distance isn't.
Right. So a lot of kids make the assumption that just because it's going to start going down, but really it's going to keep increasing. Time is increasing, but distance is staying the same. And then what's the last line going to look like? What's the last line going to look like? Jordan?
Going down.
It's going to go down. Is it going to go like this?
No.
It's going to go which way? What direction? Positive or negative slope? Okay, is it going to look like this? Is it going to be the same?
Yes.
What's going to be different? What will be different, Jordan? No. Then it says, then she raced home at 60 miles per hour to find her purse. Logan.
Because she's going faster now at 60 miles per hour instead of 45. So the time will be less since the distance is going faster. The time will be less, so it's going straight down faster. It's still not like a perfect.
Can anybody use a word for that? When we talk about the slant of a line, Molly? It's a different slope. It's a steeper slope. It's not a straight line, but it's a steeper slope. You described it perfectly, but it's slope that we're talking about. All right, so when we're graphing this, you notice that the line, it is a solid line because every second that it's being recorded, I'm gaining distance, right? Or I'm gaining time. I'm gaining one of the other. So I'm connecting those points. And this is what we would call a continuous line. Is everybody clear on that? That is continuous. Can I keep going?
No.
Okay, I'm going to pause it. All right. So Martha will put a quarter in her bank every day starting Monday except on weekends. Graph her total savings over the first 10 days. Okay, one more time. We're comparing two things. What are the two things? Anthony?
Time.
And money. Okay, what is my depender? What goes on the y-axis? McKenna?
The thing that goes on the y-axis is the money.
Money. And time is our independent. The more time I have, the more money I will save. If I only have a day, I'm only going to make a quarter. If I have, 10 days, I'm going to make $250. Does that make sense? All right, so we are having time, savings, and our time, which is days. Okay, so Martha will put a quarter in her piggy bank every day starting Monday except on weekends. So if I were going to start graphing this, what would it look like? What would it start to look like? What's the first thing I would do? Yes, McKenna?
You would graph at the 25 mark on the first day.
Okay, I would put a point, right? Or we could say at 0, I have 0, right? Okay, on day 2. Day 2, everybody. I have 50 cents. On day 3. On day 4. Day 5. Okay, day 6.
Nothing. You don't.
I do. I have 125. What do I have in my account on day 6? 125. What do I have in my account on day 7? Sunday. 125. And then day 8? Day 9? Day 10? $2. So I guess it's not $250. Why is it not $250? Yes, Vardon? Yeah, we don't put quarters in on the weekends. Now, would I connect these points? Yes or no? And why? Why?
You would because it's a continuous line.
Okay, you're not telling me, you're using the language that I've taught and not telling me why I would connect. Molly?
I don't think you would because you can't have like half a day, so you wouldn't connect it because what you would be doing is if you were to draw a line, that would mean that it would continue in the middle of where a square is, and you can't have that because that would mean that you'd have more than 25 cents on that day, and that half a day, which you wouldn't.
Because I'm not depositing at every second of the day. Do you understand that? I'm only depositing once a day. I'm not depositing 32.5 seconds. I put 1/4 per 1 day. That's it, that point. Jump to day 2. I'm not doing anything at day 1.5. Do you understand why I'm not connecting those points? Because the data in between, it's really just points. Now, if we want to show this continuing, well, we wouldn't. So this is what we call a discrete line. A discrete line. We wouldn't show this continuing on and on forever because you've got that break of the 2 days, right? Of not inputting it. Does that make sense? Yes.
You had the break in the other example too when she stopped at the gas station and when she went back down for her purse. So why would in this scenario the weekend's affected? Because it's the same pattern. It would just keep going on.
No. You're missing my point. I'm not saying that this pattern's not going to continue. I'm saying you're not putting an arrow here. We're not putting an arrow here because that implies it's going in the same exact line. And it's not. It's going to have that. It might have the same pattern, but not the same line. So this is when you don't connect the points. What's it called? And when you connect the points, so it's when your time is constant or your quantities are constant. Okay? Questions? All right, so now we're going to go to talk about functions. Function is a rule that describes a dependent relationship between two quantities. Within the function, we have domain, which is our inputs. And this is also called, I like you to know two things. It's our inputs, it's our x values. It's the fancy word for x values. And then we've got our range, which are our outputs. Which are our y values. You guys with me? So a function is a rule that describes a dependent relationship between two quantities. Domain is our input or our x values. Our range is our output or our y values. Pause the recording and finish taking notes. Okay, so we are going to take a look at this scenario of this pattern that continues to grow. So we're going to say that n is the number of triangles and p is the perimeter of each figure. What would be my depender in this situation? What is the depender? Jordan?
The perimeter.
The perimeter depends on the number of triangles. So perimeter is going to go in for the x or the y?
Y.
Y. And the n is for our x. Our depender is always our y, and our independent is our x. So I'm putting that as P. So if I were going to create a table on the first triangle, what would we put for our number of triangles to perimeter? What would the ordered pair be? How about Arabella?
It would be
How many triangles for the first triangle?
1,
1. And what is the perimeter?
3.
Good. The next one, Arabella?
It would be 2, 4.
Good. Next one, keep going, Vardon.
It would be 3, 6.
3 triangles.
3,
1.
3, 9.
What? 3, 9? Okay, a perimeter is like your fence that surrounds. Yep, it would be 3, 5. Okay? Okay, the next one, Vardon.
4, 6.
4 triangles. Yep. Can we guess what the next pair would be, Sean?
5, 7.
And the next one, please, Logan.
6, 8.
Good. Okay, so now we can really write an equation based on this. Okay, so what would I need to do to write the equation? What do we need to write an equation? Yeah.
You find slope
And a slope.
and the line.
y-intercept. So let's find the slope. How do I find the slope? Yep.
You take 2 points and you can do this slope formula.
Okay. And so let's take these two. So what am I putting up top? Let's do it here. McKenna?
You put the 4 and the 3 on top.
4
Minus 3
over.
over 2 minus 1.
Good. And what does that equal to?
1 over 1.
1 over 1. Good. So my m equals 1. Okay. Now I need my b. How do I find my b? Somebody have Logan.
Never mind.
Chris?
You use one of the points and you use the point slope formula.
Okay, and I've got 1. Y minus y1 equals m times x minus x1. Y minus what?
Y minus 3,
Equals
1 times the quantity of x minus
1. Good. Y minus 3 equals x minus 1. Add 3, add 3. Y equals x plus 2. Now, of course, we've got to switch it to, what is my y? P equals n plus 2. There is the equation that describes the relationship of triangles to perimeter. Yes, Molly?
Didn't before we talk about how if you have a table like this, where one side is 1, 2, 3, 4, 5, and the other side is a set of numbers, how you can find
We are just about to talk about that very quick shortcut. So, if we have a constant rate of change, and you will notice that this and this and this is all increasing by what? 1, 1, 1. And this is all increasing by, what can we find with that? What are we finding with that? Increase, yes.
that the increase of 1 is the same as 1 over 1, which is the slope.
Okay, so we can say that the change in the y over the change in the x, right? If they're a constant rate of change, I can just do that. It's 1 over 1. The change over the change. I could have done that without plugging anything in. I could have just gone m equals the change over y. You got to remember that. The y is on top, right? So you've got to do that. Make sure that the y is on top over the change in the x. And then we get 1 over 1. We can also find this y-intercept here. To find a y-intercept, what must happen? Chris? Kendall?
Don't you subtract P or N from P?
Not n from p, but Daniel?
Well, you can use y equals mx equals b, and then you can substitute.
Too much work. I'm already doing that. I want to go the shortcut. What do we know? With a y-intercept, what is always going to be? What is always going to be, Mary?
X equals 0.
X will equal 0. So if I can get my table to the 0 point, right? Can we get this table to the 0 point where x equals 0? Okay, we know that it's decreasing by 1. So, right? If 2 minus 1 is 1, 1 minus 1 is 0. And what is this decreasing by?
1 over 1.
So what's that going to be? 2. That is the point where that is your b. So I know my b is 2, my m is 1. So it's y equals 1x plus 2. P equals n plus 2. Does that make sense? Now that only works if this is a constant rate of change and this is a constant rate of change. Yes?
It doesn't really make sense because if you have 0 triangles,
It doesn't make sense in the context, but it does make sense mathematically. How do we get to our y-intercept? Is when x is equal to 0. You're right. You're not going to have a triangle with 2 sides. Yes?
Why do we assume that the perimeter is 1 for a side.
It's 1 unit. I don't know. We just always assume 1 unit. Yes.
Because you can see the line on each side, just showing that each side is congruent.
Yes. All right. So next, then I can graph it. I'm going, because this is a very long lesson. So I'm going 1 triangle for 3. 2 triangles is 4. 3 triangles is 5. 4 triangles. Tell me, is this discrete or continuous?
Continuous.
McKenna, thoughts?
It's just, well, it'd be discrete because you can't really have, there's not really like a half triangle.
Right. You take one side away, it's no longer a triangle. So it is discrete.
Discrete because it's only, the perimeter is only when you have one, like, full triangle, or like 2, or.
Do you understand? So it's 1 triangle. What's the perimeter? 2 triangles. You're not going to have half a triangle. You can't have 2.5 because as soon as you take one side away, it's a triangle is a 3-sided closed figure. Does that make sense? So it would be a continuous. Now notice, this line continues in the same pattern. It's the line continues, so I put that little arrow there. Does that make sense? Okay. Now, pause the recording. You're going to do the next one on your own. We've already found our. So, we're going to say N stands for the number of hexagons and P is the perimeter. I'd like you to write the equation. Go. Make a table, graph it, and write the equation. I'm going to give you 2 minutes. Let's check out what you have. So your table. For 1 hexagon, what did you get? How about Kendall?
8, 10.
What was the perimeter?
Oh, 1 hexagon, I got 6.
Good. And 2?
10,
Good. And 3?
14,
Good. 4?
18.
Good. Malcolm?
Yeah.
Keep going?
5 would be 22. 6 would be 26.
Okay. And who can tell me what the y-intercept would be? Somebody I haven't heard from, please. Sam?
0.4.
What? I want to know what the y-intercept would be. Okay. If I go to the 0, I'm noticing it's decreasing by 1. What is it decreasing by, Sam?
Oh, it'll be 0. It'll be the y-intercept would be 2.
Okay, the y-intercept would be 2. So my b would be 2. And what is my slope? Remember, we're doing change over y over change over x. They seem to be constant. Sean?
My slope is 1/4.
No. It's the change over y is what?
4.
Over 1. And so what is my slope? 4. So my equation would be p equals 4n plus 2. Is everybody understanding? And if I were to graph it, would it be discrete or continuous? Discrete. Because we're not going to take part of a hexagon. Now, do you understand why that arrow is there and it wasn't on the first one where it had the 2 days? Okay. Okay. So let's look at one more. A car's fuel tank is filled at a rate of 1.6 gallons per minute. The tank held 5 gallons of gas before refueling. So tell me, do you think this is going to be discrete or continuous? As I'm filling gas in my tank. Daniela, it's going to be continuous because you're not going to stop every minute. One shot. Take you forever to put your gas in there, right? Okay, so basically we're going to, now, if it held after 0 minutes, what is going to be my y-intercept? What is my y-intercept? Anthony? 5. It starts at 5. At 0 minutes, I have 5 gallons, right? Now, I can still go in units of 2. And so at 0, I have 5, and then I'm adding 1.6, no, we're,
3.2 for 2 minutes.
right, okay, that's right. So this ends up being our slope. So, and we'll see, I just really wanted you to compare, you're right, 3.2, because they're giving us our slope. If they're giving us a rate, it's 1.6, sorry, and this is gallons per 1 minute. Do you see how that is? That's your change in your y over your change in your x. And we said it is going to be continuous. We connect the points. Questions? Vardon?
Well, wouldn't there be a limit of how much gas?
Yeah, which we're going to talk about limits towards the end of this. All right, so now we talk about relations, domain, and range. We said our domain is our x values, our range is our y values. So, x values, y values. These are our x values, and these are our y values. So, if I'm going to write the domain is equal, what is my domain? What are the numbers in that number set that make up the domain, Chris?
2, 3, 4, and 5.
Good. And what would make up the values for my range? Vardon.
5, 7, 9, and
Is everybody remembering this? Okay. You guys do number 2. Put it on pause. And please list the domain and range. I'm going to remind you, this is your x, this is your y. X, y, x, y, x, y. These are your x values. You're just putting them in a group. These are your y values. Go. So let's go with Litzy. What did you get for the domain?
-3, -2, -1,
And what? And 1. Good. Kendall, what did you get for the range?
10, 10, 6.
Okay, with this, we don't need to write the repeats. We just write, so get rid of the repeat. We're only listing the possible elements that could be the domain. So I don't need to write 10 twice. There's only one 10. Does that make sense?
Yep.
Okay, so now we're going on to a relation is any set of ordered pairs, as opposed to a function has a relationship. And it's a dependent relationship. A relation can be any set of ordered pairs, but a function, basically the rule for a function is there can be no repeated x values. No repeated x values. Okay? No repeated x values to be a function. Can y be repeated? Yep. Okay, from the table, can we see if this is a function? Yes, because the x's don't repeat. This is what we call mapping. And so we list all possible x's and all possible y's. And we don't write any repeats. And then we do an arrow. 1 goes with 6. 2 goes with 7. 3 goes with 7. In the map, if 2 arrows come out of the same x, it's not a function. What this really means with that arrow is 1, 6. What this means is 2, 7. And this means it's 3, 7. Do you understand? It's just you have to understand it. We don't use it a lot, but if they give you a map, you should be able to list the ordered pairs. You should also be able to list the domain and the range. Domain is your x, range is your y values. Fancy words. Are there any questions so far? Somebody said, do I have to write a map for everyone? No. But if they give it to you, you have to understand it. If they ask you to map it, then this is what you're doing. Okay, so let's look at the next one. Is this a function? No, because the x values repeat. If I were writing it in the map, My values for x are 1 and 2. My values for y are 6 and 7. And I'm going to draw my arrows. 1 goes with what? 6. And 1 also goes with 7. 2 goes with 7. Do you see this point here? When there's 2 lines that come out of one x, it means it's not a function. So you have to be able to identify from the table if it's not a function, and you have to be able to identify it from the map. Does that make sense? Yes, Chris.
Why can't it be a function?
When x repeats, it's not a function. You can either memorize the definition, or it's only considered a function if there's only one output for any input. Yes.
Should there be a line going from 7 into 1? Because they...
I did 1 from 7, 1 to 7, right here.
Oh,
Right here. Okay? All right, so now let's move on to, I get like confused with that definition, so I always remember there's no x values. So is this a function?
Yeah.
Because the x's don't repeat. Okay, is this a function? Why? Okay, they're different, so is this a function?
No.
Why? Is this a function? No, because x repeats. You got it right and they got it wrong, right? Okay, okay, sorry. So this is not a function because the x repeats. Okay? Now, if I were to do something like this, yes, question.
What if the x repeats, but it's with the same y number?
Same y number, then it's the same value. It's the same point. It's not, the rule is 2 points can't be going through we'll tell you the vertical line. Hold on, I'll go back to that. Let me come back to that. Okay, y equals absolute value of x. In this case, I choose my x's, right? Where the absolute value is. I'm going to choose some negatives, some positives when I substitute in. Okay, nothing repeats, right? It's a function, right? When I plot this, it's going to look like this. Oops. Right? You're going to have here. It's going to look something like this. Right? Here's 1, here's 2. It's going to keep looking like that. That's an absolute value function. Okay, the next one. All right, so now when you have this situation, they're asking us to take the absolute value of y. We choose our y's, right? You can see from the map on absolute value of x, it is a function. This time we're choosing our y's. And so when I take the absolute value of -2, I get 2. When I take the absolute value of 1, I get 1. And when we go, you can see that this is no longer a function. We can put it into the map, and you can see that 0 goes with 0. And you can see that it is not a function. We have 2 arrows coming out of 2, and we have 2 arrows coming out of 1. Also, when you go to graph it, you're going to look at it and it'll look something like this. It won't pass our vertical line test, which we're about to talk about. All right, so let's then go to tell whether this is a relation or a function. Number 1, take a minute, pause the recording, and let me know what you think. All right, number 1 is a function because no x's repeat. Number 2 is not a function because the x's repeat. Number 3 is a function because the x's do not repeat. And number 4 is not a function because the -2 repeats. Okay, which brings us to our vertical line test. So we have a test. In the table, we know it's not a function if x doesn't repeat. In a map, we know it's a function if you don't have 2 arrows coming out of the x. In a graph, it is considered a function if no x's repeat. If our vertical line can pass the test, I run a vertical line through it, and if it doesn't cross the vertical line at two places at the same moment in time, it is still a function. So you can see as I run my vertical line through, it does not cross at any one time. It only crosses at one point in any given moment of time. Number two, if we look at you see it doesn't cross the vertical line at two times in the same moment. So it's a function. As I run my vertical line through on the horizontal line, it too is a function because it doesn't cross that vertical line two times in the same moment. Now, as you see, when I put my vertical line, it crosses every point. So this is not a function. If I were to do a table for that, it would look like this, x, y. So it'd be 2, 0, 2, 1. You can see 2, 3. It repeats in the x column. So the vertical lines repeat in the x column. Let's look at the next one. As I run my vertical line through, we can see in the parabola that it never crosses at any one moment. Even the parts where the arrows are going up, there's no straight line. It's always at a slant, that slope. So it is a function. On the next one, you can see that it is, as I run my vertical line through, it crosses at 2 points in the given moment. So it is not a function because it does not pass the vertical line test. The next one, as I run my vertical line through, it passes the test. Number 3, the next one is not a function because it doesn't pass the vertical line test. And the last one is not a function because it does not pass the vertical line test. All right. So, number 1, pause the recording and try these. Now check your work. Number 1, is a function because no x's repeat. Number 2, is a function because it passes the vertical line test. Number 3, is not a function because it does not pass the vertical line test. And number 4, is not a function because 5 has 2 outputs. All right, so now we're going to talk about domain and range. And this is leading us to our big project, which is we'll start at the beginning of the year. So with domain, we can see that on the first one, that point is -2, 1. The second point is -1, -3. Okay, so as I mark my points of each one, now we can see that our domain is -2, -1, 2, and 4. My range would be 1, -3, 2, and 2. Is this a function? Yes, because the x's don't repeat. On number 2, the domain means how wide is it? This is going to keep going on and on and on, this slant. So eventually it will pick up every single x, and this too. So what we would write for that is the domain is all real numbers. X is an element of the reals. Now the range, on the other hand, is how high and low can the range get? Well, we know it has a boundary, and that boundary is -3. So we would say y is greater than -3. Greater than or equal to. Number 3, as you can see, if I'm looking at the width, that's just this area in here. So we would say the domain is between -1, -2 is less than or equal to x, which is less than or equal to +2. Close it up. And then the range is how high is it? Right? So I'm looking at from here to here. So from the range is from -1 is less than or equal to 1, 2, 3, positive x, which is less than or equal to positive 3. Remember, you must go from lowest to highest when you're writing the in-between statements. Now again, the domain is your x values, your width. What's the widest it can go? It goes on and on forever in the right direction, but in the left, it has a boundary of -2. So x is greater than or equal to -2. And my range is going to be higher than 0. So y is greater than or equal to 0. So with that in mind, that is the recording, and we are done.